Hello and welcome to SpaceTime, the channel where we explore the mysteries of the universe. In this video, we'll talk about the Big Bang, the event that started it all. The Big Bang theory is the best scientific explanation we have for the origin and evolution of the universe, but it does not tell us what caused the Big Bang, or what was the state of existence before it. There are several possible scenarios that have been proposed by physicists and cosmologists, but they are all speculative and not well tested by observations. Here are some of them. One possibility is that there was nothing before the Big Bang, and that the Big Bang created both time and space as we know it. According to this view, the Big Bang was a singularity, a point of infinite density and temperature where the laws of physics break down. Asking what happened before the Big Bang is like asking what is north of the North Pole. There is no before, because time itself began at the Big Bang. Another possibility is that there was something before the Big Bang, but it was very different from what we experience today. For example, some physicists have suggested that the Big Bang was the result of a collision between two higher-dimensional objects called brains. This is part of a theory called ekpyrotic theory, which is inspired by ancient Greek cosmology. According to this theory, the Big Bang was not the beginning of the universe, but a transition from a previous phase of existence. A third possibility is that there was something before the Big Bang, and it was similar to what we have today, but in a different cycle. This is the idea of a cyclic or oscillating universe, where the universe goes through repeated periods of expansion and contraction. According to this theory, the Big Bang was not the first, nor the last, but one of many in an eternal sequence of cosmic rebirths. A fourth possibility is that there was something before the Big Bang, and it was a quantum fluctuation in a vacuum. This is based on the idea that even in empty space, there is a constant activity of virtual particles popping in and out of existence. According to this theory, the Big Bang was a random event, where a tiny fluctuation of energy grew into a massive explosion, creating our universe out of nothing. These are just some of the possible scenarios that have been proposed to explain what happened before the Big Bang. However, none of them are conclusive or widely accepted, as they face many conceptual and observational challenges. To answer this question, we would need a complete theory of quantum gravity, which would combine quantum mechanics and general relativity, the two pillars of modern physics. Such a theory is still elusive and may require new experiments and observations to test it. Until then, the question of what happened before the Big Bang remains one of the greatest mysteries of science. The Big Bang is a scientific theory that describes how the universe began and evolved. It is based on observations, experiments, and mathematical models that explain the origin and structure of the cosmos. Here are some more details about the Big Bang. The Big Bang was not an explosion in space, but an expansion of space itself. It means that every point in the universe was once very close together and then moved apart as space stretched. This is why we see distant galaxies moving away from us, because space is still expanding. This phenomenon is called the redshift, and it is one of the main evidences for the Big Bang. The Big Bang started from a singularity, a point of infinite density and temperature, where the laws of physics break down. We do not know what caused the singularity or what was before it, because our current theories cannot describe such extreme conditions. Some possible scenarios include a collision of higher-dimensional objects, a quantum fluctuation in a vacuum, or a cyclic universe. The Big Bang happened about 13.8 billion years ago, according to the measurements of the Cosmic Microwave Background, CMB. The CMB is the leftover radiation from the early universe when it was a hot plasma of particles and light. As the universe expanded and cooled, the plasma became transparent and the light escaped. We can see this light today as a faint glow in the sky, which shows us the temperature and density variations of the primordial universe. The Big Bang created the basic ingredients of matter, such as protons, neutrons, electrons, and photons. These particles formed the first atoms, mostly hydrogen and helium, in the first few minutes after the Big Bang. These atoms later clumped together under gravity to form the first stars and galaxies, which produced heavier elements through nuclear fusion and supernova explosions. These elements are the building blocks of everything we see today, from planets to people. The Big Bang is the scientific theory that explains how the universe began and evolved. It is based on several pieces of evidence that we can observe today, such as the redshift of galaxies. This means that the light from distant galaxies is shifted to longer wavelengths, or redder colors, as they move away from us. This is a consequence of the Doppler effect, which is the change in frequency or wavelength of a wave due to the relative motion of the source and the observer. The redshift of galaxies indicates that the universe is expanding, and that the farther away a galaxy is, the faster it is moving away from us. This implies that the universe was smaller and denser in the past, and that it originated from a single point. The cosmic microwave background, CMB, this is the faint glow of radiation that fills the entire sky. The CMB is the leftover heat from the Big Bang, when the universe was a hot plasma of particles and photons. As the universe expanded, the plasma cooled down and became transparent, allowing the photons to escape. These photons have been traveling ever since, and we can detect them today with special telescopes. The CMB shows us the temperature and density fluctuations of the early universe, which are the seeds of the galaxies and stars we see today. The abundance of light elements. This refers to the amount of hydrogen, helium, and lithium in the universe. According to the Big Bang theory, these elements were formed in the first few minutes after the Big Bang, when the universe was hot enough for nuclear fusion to occur. The theory predicts the exact ratios of these elements, and they match the observations very well. The evolution of galaxies. This means that the shape and structure of galaxies have changed over time. By observing galaxies that are very far away, we are also looking back in time, because light takes time to travel across the universe. We can see that very old galaxies are very different from newer galaxies, which shows that the universe has changed. This evidence fits better with the Big Bang theory than with the alternative theory of the steady state, which assumes that the universe does not change much over time. The Big Bang is the scientific theory that explains how the universe began and evolved. It is based on several pieces of evidence that we can observe today, such as the redshift of galaxies, the cosmic microwave background, and the abundance of light elements. However, despite its name, the Big Bang did not make a sound, at least not one that we could hear. According to the web search results, the Big Bang was not an explosion in space, but an expansion of space itself. It means that every point in the universe was once very close together and then moved apart as space stretched. This is why we see distant galaxies moving away from us, because space is still expanding. The Big Bang started from a singularity, a point of infinite density and temperature where the laws of physics break down. We do not know what caused the singularity or what was before it, because our current theories cannot describe such extreme conditions. The Big Bang was silent because there was no medium for sound waves to travel through. Sound waves are vibrations of matter that need a medium, such as air, water, or metal, to propagate. Without a medium, there is no sound. The Big Bang created the basic ingredients of matter, such as protons, neutrons, electrons, and photons, but they were not organized into atoms or molecules yet. They were in a state of hot plasma, where the particles were too energetic to form bonds. The plasma was also opaque, meaning that light could not escape from it. Therefore, the Big Bang was both silent and dark. The Big Bang became audible only after the universe expanded and cooled enough for the plasma to become transparent and for the first atoms to form. This happened about 380,000 years after the Big Bang, and it is known as the recombination epoch. The photons that were trapped in the plasma were finally released, and they are still observable today as the cosmic microwave background. The CMB is the oldest light in the universe, and it shows us the temperature and density fluctuations of the early universe. The CMB also contains information about the sound waves that existed in the early universe. These sound waves were not produced by the Big Bang itself, but by the pressure and gravity of the plasma. The pressure tended to push the plasma outward, while the gravity tended to pull it inward. This created oscillations or vibrations of the plasma, which are the sound waves. These sound waves left imprints on the CMB as they affected the temperature and density of the photons. By analyzing the CMB, scientists can reconstruct the sound waves of the early universe and even listen to them. A physicist at the University of Washington named John Kramer decided to recreate the sound of the Big Bang using data from a satellite that measured the CMB. He fed the data into a computer program, which converted it into sound. However, the sound was so low, so bass, that it was inaudible to humans. Kramer had to boost its frequency 100 septillion times to make it audible. The result was a robotic humming sound that lasted for about 100,000 years. The Big Bang was the beginning of the universe, but it was not a loud or explosive event. It was a silent and dark expansion of space that created the matter and energy that we see today. The Big Bang became audible only much later, when the universe became transparent and the first atoms formed. The sound of the Big Bang was a long and low humming that we can still detect in the cosmic microwave background. The Big Bang was the birth of sound, but it was also the silence of the singularity. Unfortunately, we will never be able to see the Big Bang. Even though we are looking back in time, right to the edge of the observable universe, it is just beyond our reach. The reason is that the light from the Big Bang has been stretched out to the point that it is no longer visible, but has become microwaves. It is only with sensitive radio telescopes and space missions that astronomers can detect it. The Big Bang is the beginning of the universe, but it is also the end of our vision. The ultimate fate of the universe is a topic in physical cosmology that explores how the universe will evolve and end in the future. There are several possible scenarios that depend on the amount and nature of matter and energy in the universe, the rate of expansion, and the shape of space. Based on the available observational evidence, the most widely accepted scenario is that the universe will continue to expand forever, becoming colder, darker, and emptier. This is because the universe is dominated by dark energy, which is a mysterious form of energy that causes the expansion of the universe to accelerate. Some of the other possible scenarios are the Big Crunch. This is the opposite of the Big Bang, where the universe stops expanding and starts contracting due to the gravitational attraction of matter. The universe becomes denser and hotter until it collapses into a singularity, a point of infinite density and temperature. This scenario requires that the universe has more than a critical amount of matter, and that dark energy is negligible or negative. The Big Rip. This is a scenario where the dark energy becomes so strong that it overcomes all the other forces in the universe and tears apart everything, from galaxies to atoms, in a finite time. The universe ends in a state of infinite expansion and zero density. This scenario requires that the dark energy has a special property called phantom energy, which makes it increase faster than the expansion of the universe. The Big Freeze. This is a scenario where the universe continues to expand, but at a slower rate than the dark energy. The universe becomes colder and darker as the stars burn out and the galaxies move away from each other. The universe ends in a state of thermal equilibrium, where everything has the same temperature and no energy can be transferred. This scenario requires that the dark energy has a constant value, and that the universe has less than a critical amount of matter. The Big Bounce. This is a scenario where the universe undergoes a cyclic process of expansion and contraction, similar to a bouncing ball. The universe alternates between Big Bangs and Big Crunches, with each cycle lasting billions of years. The universe may have different properties and laws of physics in each cycle. This scenario requires that the universe has a special property called quantum gravity, which prevents the singularity from forming and allows the bounce to happen. These are some of the possible scenarios that have been proposed to explain the ultimate fate of the universe. However, none of them are conclusive or widely accepted, as they face many conceptual and observational challenges. To answer this question, we would need a complete theory of quantum gravity, which would combine quantum mechanics and general relativity, the two pillars of modern physics. Such a theory is still elusive and may require new experiments and observations to test it. Until then, the question of what will happen to the universe remains one of the greatest mysteries of science. This is the end of this video. I hope you learned something new and interesting about the Big Bang and the fate of the universe. If you have any questions or comments, please leave them below and I will try to answer them. Thank you for watching SpaceTime. If you enjoyed this video, please like, share, and subscribe. And don't forget to hit the bell icon to get notified of our latest videos. See you next time.